Example 7. More substitutions with trig identities. Take a second, copy parts A through D down, and then we're going to go ahead and work all of these out. I really recommend that you do try these on your own. See how far you can get on your own. And then if you're stuck, watch me work them out. And then once you get past the point where you're stuck, try to keep going on your own. It's very important that you kind of understand how to solve these puzzles because I won't be with you on the AP test. Alright, so here we go. So let's start with A. The integral of dx divided by cosine squared of 2x. Now notice that I don't know what the integral of cosine 1 over cosine squared 2x is. But what I can do is I can rewrite this as the integral of secant squared of 2x dx. And I do know the integral of secant squared. But I have a 2x in there. I got to get rid of that. We're going to let u equal 2x. So du is equal to 2 dx. But I don't have a 2 running around, so I got to divide both sides by 2. So I get 1/2 du is equal to dx. So we get the integral of secant squared of u, and dx is replaced by 1/2 du. So this becomes 1/2 the integral of secant squared u du, and the integral of secant squared is tangent of u plus c, and we replace the u back and get 1/2 tangent of 2x plus c. That one's not so bad. Now let's do part B. So part B says we want to integrate cotangent squared of 3x dx. Well, this is where we start running into some problems. And the first problem is that we don't know the integral of cotangent squared. But we do know that cosecant squared of x is equal to cotangent squared of x plus 1. And if we solve that out, we can get cosecant squared minus 1 is equal to cotangent x squared. So we also know that the derivative of cotangent is negative cosecant. So we're going to use that in our integral. Also, if you forget any trig properties, you can always derive them from sine squared plus cosine squared equals 1. You see right here, I can just divide everything by sine squared, and I can get the one with cotangent and cosecant in it. If I were to divide by cosine squared, I could get the one with secant and tangent in it. So back to our integral, we're going to get that this is equal to the integral of cosecant squared of 3x minus 1 dx. So I can't integrate that yet. I'm going to need a u sub. So I'm going to let u equal 3x because of this right here. So I take the derivative and I get du equals 3 dx. But notice that I don't have a 3 dx, I only have dx. So I need to multiply both sides by 1/3. So now I'm going to rewrite my integral, and I get this is the integral of cosecant squared of u minus 1 times 1/3 dx. So I'm going to go ahead, I'm going to bring that 1/3 out of the integral. You can distribute it if you want as well. I like to bring my constants out if I can. And now I can go ahead and I can integrate this. So this is going to be equal to 1/3 negative cotangent of u minus u plus c. And I get this is equal to 1/3 times negative cotangent of u. Nope. I'm going to switch back the u for 3x minus 3x plus c. I'm going to distribute that 1/3, and I get negative 1/3 cotangent of 3x minus x plus c as my final answer. Alright, now let's move on to part C. Part C, it said this is the integral of cosine cubed of x dx. Well, I don't know the integral of cosine cubed. What I do know is the integral of cosine, and I do know how to make cosine squared into something a little different. So I'm going to rewrite this as the integral of cosine squared x times cosine of x dx. Typically, when a trig function is above the power of 2, this is a very common technique to do. So this is going to be the integral of, and I'm going to rewrite cosine squared as 1 minus sine squared x cosine of x dx, because now I can let u equal sine of x, and so I'm going to get du is equal to cosine of x dx. Notice now that I have my u sub. So I can rewrite this as the integral of 1 minus u squared du. Now I can integrate this, and I'm going to get u minus u cubed divided by 3 plus c. And I put the u back for sine, and I get sine of x minus 1/3 sine cubed of x plus c. And there's my answer. Not so bad. Not so bad. And the last one, part D. This one gets a little tricky. I might need some more room. I'm going to go this way. So we get the integral of sine of 3x times cosine of 3x dx. Now if I tried to use a u sub here, I could let u equal 3x, but I don't have a 3 anywhere, and that doesn't get rid of cosine. I could let u equal sine of 3x, but then I am still left with some stuff I don't know. So what I need to do then is use a trig identity. And here is the trig identity. This is a double angle formula that you need to know. So we know sine of 2x is equal to 2 sine of x cosine of x. So all I need to do is make sure that that's the same as that, and I can rewrite it as 2 times the angle with only sine. I also need to make sure that I have a 2 out in the front. Well, I don't have that yet, but that's alright, I can make it. So my goal is to have a 2 right here. Well, I can make that happen by multiplying by 1, or a very clever one, 2 over 2. So this is sine of 3x cosine of 3x dx. Notice that this piece is just equal to 1, so I can multiply by it. I'm going to take this numerator, and I'm going to put it inside of the integral. So this is equal to 1/2 the integral of 2 sine of 3x cosine of 3x dx. Now notice that I have my 2, and I have the 2 angles that are the same. So I can rewrite this as 1/2 the integral of sine of 2 times that angle, which is 2 times 3x dx, which is going to be 1/2 the integral of sine of 6x dx. Now I can use my u sub. So I'm going to let u equal 6x. I get du is equal to 6 dx, but I don't have a 6 dx, I only have a dx. So I get 1/6 du is equal to dx. So this is equal to now 1/2 the integral of sine of u times 1/6 dx. So this is 1 over 12, the integral of sine of u dx. Now I'm going to integrate that, and I'm going to get 1/12 times negative cosine of u plus c, which is negative 1/12 cosine of 6x plus c. That one is just a little bit tricky.